Okay, so we're going to take this a little bit differently today. I am going to work through the problems and you're going to watch this video and how I do these problems. Now, yesterday we should have gotten through number 1 on this paper, which is finding the molar mass of each of these. And from the molar mass, you find out which percentage each element makes up the compound. Now, we are going to use all of this information down here on part 2. Okay, so each of these percentages you found will become useful. Now, I'm going to start with number 5. Number 5 asks, how many grams of hydrogen can you expect to see in 100 grams of hydrogen bromide, or HBr? Now, if you take a look, this HBr connects to number 1. So if I go look back at problem number 1, see we have HBr, we were asked to find grams of hydrogen. And here we can see that we already found out what percent hydrogen makes up this compound. It makes up a total of 1.25%. So I'm going to use that percentage on this problem. So I'm going to write that down. I know that hydrogen makes up 1.25% of HBr. Now, in order to find the grams, so grams is what I'm looking for here, I'm going to set up a proportion. All right, this first side is going to be what I'm given in this particular problem. So I am given the fact that I need to find grams of hydrogen. So that's what I'm looking for. And I'm also given 100 grams of HBr. So I'm going to put that 100 grams HBr on this side. On the other side of the problem, I'm going to use all of the information I can find from part 1. So in part 1, we found that hydrogen makes up 1.25%. So let's go ahead and use that number here. I need 1.25% out of 100%. Now, if I were to cross multiply, so multiply 100 times 1.25 and then divide by 100. So cross multiply and divide, we get a total of 1.25 grams of hydrogen. And that's your answer. So let's go to number 6. Let's try number 6. Number 6 asks, how many grams of oxygen, so this time we're trying to find oxygen, when we're given 85.5 grams of H2O2. So this one, like I said, it connects to the top on part 1. This one connects to problem number 2. So if I go look at problem number 2, and again, we're trying to find grams of oxygen. Problem number 2, H2O2, I know that oxygen is a total of 94.06%. So I'm going to write that down here so I can remember that number. I know it's 94.06%. But how many grams can that percentage give me? So let's go ahead and set up our proportion. So again, this first part is what we're given in the problem. So I know I need to find grams of oxygen whenever I'm given 85.5 grams. 85.5 grams. So out of H2O2, how much is that is oxygen? Is pretty much what it's asking. And then the second part is what we have from part 1. And I know from part 1, 94.06 out of 100% is oxygen. So now let's go ahead and cross multiply 85.5 times 94.06. And to show y'all how I do this, let me pull up my calculator. Let me find the calculator first. Calculator. Boom. Let it load. Give it a second. No, I don't want an ad. Let's clear everything out. Okay. let's pull up a double screen here so y'all can see, we can see what we're doing. So we were here, we are trying to cross multiply 85.5 times 94.06. Now we need to go ahead and divide by 100. So I'm going to divide this number by 100, and that gives me a total of 80.42 grams. Why is my pen? Oh, it is working. 80, nope, now we're in highlighter. 80.42 grams of oxygen. So that's how we do this side. All right, that's how we do this side. If you labeled yours like I labeled mine, you should have one side as what you're given in the problem. The other side is the information from part 1. Okay, and I am going to skip over 7 and 8 so y'all can practice these on your own. Let's go down to the second page. Now, this one, we are going to be determining formulas. Now, what does that mean? So if I were to scroll back up to part 1, on part 1, we were given a formula and we had to figure out what percentage each element made up this formula. Now we're going to be doing it backwards. We're going to be given a percentage and we have to determine the formula from this percentage. So it sounds complicated, but really we're just working backwards of what we did on part 1. So let's start with number 1. We are given 2 elements, magnesium, which is Mg, and bromine, Br. So let's go ahead. I'm gonna set up 2 tables, one for magnesium, one from bromine. Make sure you write with enough room to make 2 tables. All right, here I am given, first let's do the magnesium. I'm going to do magnesium in blue, and let's do bromine in purple. So for the blue side, magnesium, I'm going to take this percentage. Let's turn it into grams, because again, I'm trying to get it into a formula, and formulas are based off of mass and moles. So I'm going to turn that 13% into grams, as well as 87% into 87 grams of bromine. So I just split my information up into 2 tables. Okay, now, in order to change this mass from grams into moles, we are going to use the molar mass. And where do we find molar mass? Well, molar mass is from the periodic table. I'm going to label it right here so y'all know where I got this information from. So if you were to look at your periodic table, let's see if I can just go Google one real quick. So ignore any tabs that I have open. I don't even know what's open here. All right, so for the periodic table, let me pull up, I don't remember what elements. I need to find magnesium and bromine. So magnesium has a weight of 24.035. So if we round that to 2 decimal points, that'll be 24.31 grams for every 1 mole. All right, now let's look at bromine, Br. Br is right here. So Br, bromine, we get 79.90 grams for every 1 mole. All right, let's close out that tab. Let's go back to our paper. So at this point, this looks familiar. We have grams on top and bottom, and so we're gonna end up canceling out those grams and make this into moles. In order to do that, we have to take the number on top divided by the number on the bottom. So let's pull up our calculator again. So here, oh God, no, we don't want an additive township. Does anyone play that? Because I've played it before. It's low-key kind of cool. Anyways, 13 grams divided by 24 divided by 24.31. And I get this long decimal, but I only want to round it to 2 decimal points. So let's keep it at 0.53 moles of magnesium. And on the other side, for bromine, we have, on top we have 87, and we're going to divide that by 79.9. And that gives us 1.09 moles of bromine, Br. All right, at this point, I want you to take a look at what we have. We figure out the number of moles, all right, but we have to turn this into a formula. So this is kind of like a ratio. We have to pick out which one of these is actually less. And the least amount between 0.53 and 1.09 is magnesium, this one. So I am going to divide both of these by 0.53. Now on this side, 0.53 divided by 0.53 will give us 1 mole of magnesium. On the other side, 1.09 divided by 0.53. Let's go ahead and type that in. 1.09 divided by 0.53. That gives us 2.06. And we're just going to round that to the nearest whole number of 2 moles of bromine. So the reason why I round this is because now I can see that for every, hold on, let's get back to our paper. For every 1 mole of magnesium, I get 2 moles of bromine. And to write out this formula, your final answer, I'm gonna write it over here on the top. I have 1 magnesium for every 2 bromine. So MgBr2 is the answer here. And that is how we find the number of atoms, or the formula, given a percentage. Now I'm going to skip number 2 and let y'all do number 2 because it has 2 elements just like it had on number 1. And let's go ahead and do number 3. So number 3, if we work through this, I'm gonna color code again. So let's do blue, purple, and orange this time. Why not? So setting up our first table of sodium, I am going to take the percentage that you're given. Let's erase that. Take the percentage you're given, 32.38, and we're going to change that to grams of sodium. So remember, sodium is Na. Our next table is sulfur. So 22.65 grams of sulfur, S. And our last table is oxygen. Let's change this to orange. 44.99 grams of oxygen. Now, as you recall, we need to change all of these from grams to moles using the molar mass. All right, how do we find the molar mass? From the periodic table. So I'm going to pull back up my periodic table here. So on the periodic table for Na, we get 22.99 grams for every 1 mole. Now for sulfur, S, 32.065, so 0.7 grams for every 1 mole. And on to the last one, oxygen. We get a total of 15.99. If you would like to round that up to 16, that's fine. I guess we could have rounded up the other ones too. It's okay if you do. If you don't, it does not bother me. I understand both. All right. So now that we have everything written out in our tables, let's go ahead and actually do the math on these. So we're going to take the top number and divide it by the bottom number for every table. Pulling back up my calculator. So on this first one, once this add is over and done with, let me give it a second. All right. In my table, I have on top 32.38 divided by the bottom number, 22.99. So that gives me a total of, let me get back to my pen. It's, okay, 1.408. So that's 41 moles. Remember, because our grams will cancel and we're left with moles on top of sodium, Na. Now on to sulfur. I have on top, let me clear my calculator, 22.65 divided by 32.07. So here we get 0.71 moles of sulfur. So I'm going to cancel out grams because we're left with moles. The last one we have here is oxygen. Oxygen, we have on top 44.99 grams divided by 16 grams is 2.81 grams of oxygen. Now, between all three of these numbers, we have to go through and look. Which one of these numbers that we got is the least, which is the smallest? And looking at all three of these, sulfur is the smallest amount. So I'm going to divide every single one of these by 0.71. All of these numbers, 0.71. Pull back up the calculator. I shouldn't have canceled out the app. Now it's gonna make me watch another ad. Done, cancel. All right, clear it out. Okay, for this first one for sodium, 1.41 divided by 0.71 gives us one, or if let's round this to the nearest whole number. So 1.98 is going to round up to 2 moles. 2 moles of Na. Okay, so that's for our first table. We get 2 moles. Our second table, 0.71 divided by 0.71. It's the same number on top and bottom. So that's going to be 1 mole of sulfur. Let me write this towards the bottom. This is going to give us 1 mole of sulfur. And then the last table, we have on top 2.81 divided by 0.71. So this is, if we round it to the nearest whole number, it'll round up to 4 moles of oxygen. Why do I have grams? No one warned me. Why did y'all not warn me through this screen? I'm just kidding. Anyways, jokes. So looking at our answers and what we got, I now have 2 moles of Na, 1 mole of sulfur, 4 moles of oxygen. So when we put it all together at the end, I should have Na2 I should have one S, so just S. And then 4 moles of oxygen, so Na2SO4, sodium sulfate. And that is how we do number 1 and 3. Now you can look at number 1 to help you on number 2, because there's 2 elements. And you can look at number 3 to help you on these 2. Also, I am not going to teach y'all part 2 or the back page, so if you would like to cross those out, go ahead. And I recorded this video so you would actually be able to go back and watch this if you need help whenever you're studying, whatnot. You will have this to look back at to see every single step we did. So thank you.